In this lesson, we will be understanding the concept of synchronous and asynchronous programming, and also we will get familiar with concepts like async, await and future in Dart. So open up your Dart pad so you can follow along with me. Now let's get started by understanding the concept of synchronous programming and asynchronous programming and finding the difference between them, alright? And I'll try to explain it using an example. So let's create an entry point first, and here I'll be using 3 print statements. So the first one is task1 is complete, and let's duplicate it and change the numbers. So now if I run this code, what we expect it to display is that at first task1 complete will be printed, and then task2 and then task3, right? So if I run this, then I get the same expected behavior in my output, right? But what if I delete the code execution? Say for instance, I want to print this task2 completed after few seconds. So let's try delaying code execution, and we can do that in Dart by using future.delayed. And we'll have this parenthesis over here, and the first argument will be the duration. So duration, and inside of this parenthesis we'll be defining the seconds it needs to be delayed. So seconds, I want to delay it for 3 seconds, so 3. And the second argument will be the function. So let's pass anonymous function over here. Alright. Now any code that you keep inside of this anonymous function will be executed only after 3 seconds. Alright. So let me move this task2 complete inside of this anonymous function, so it executes only after 3 seconds. Alright. So we have this task1 complete over here. And then inside of this future delayed, we have this task2 complete, meaning that it will be executed only after 3 seconds. Let me change this to 1. So it will take 1 second to print this task2 is complete. And then after that, I'll be getting this task3 complete, right? So this is the expected behavior. So at first task1 complete will be printed, and then there will be 1 second delay, and then task2 complete will be printed, and then finally task3 complete will be printed, right? So now let's execute this code. And here you can see a rather strange behavior. Task1 and 3 are completed first, and then task2 is completed after 1 second delay. And this is totally unexpected. This has occurred due to a nature of asynchronous programming. So let me explain, and I want you to note this. So in asynchronous programming, every code runs independently. There is no blocking in asynchronous programming, meaning that asynchronous programming will not wait for the code execution. In other hand, if I had the same code in synchronous programming, in PHP for example, we will have got the desired result, because in synchronous programming, codes are executed in a synchronous order, meaning sequentially. In synchronous programming, if there is a delay in certain part of the code, it will wait for that code to complete and then only move forward with executing other part of the code. But in asynchronous programming, each code will run independently, meaning that nothing can hold the execution of another code. So that is the difference between asynchronous programming and synchronous programming. And because this asynchronous programming works on non-blocking mechanism, it is way faster than synchronous programming like PHP. Having been said that, asynchronous programming has one major disadvantage. So what is that disadvantage? Let's have a look. So by using this future delayed, we are intentionally delaying our code, right? But what if this code was to get a response from an API? And then after getting response from an API, I want to print the response in my debug console. Now this will be a major issue in asynchronous programming, because in asynchronous programming, code will run independently without blocking, right? So now if I run this code, task1 complete will be printed first, and then our code will try to get the data from the internet or from the API, but this print response will be printed first. So the response will be null or empty, right? Because in asynchronous programming, our code will run independently without waiting for another code to complete. But this should not be an issue with asynchronous programming, because in synchronous programming, everything will run in a synchronous order. So for fixing this issue, we need a synchronous programming behavior, meaning that in certain part of our asynchronous programming code, we need to run code in a synchronous order. So we need to request Dart to wait for the execution of this code before moving forward with other code below this line. Alright? And we can do that in Dart by using this await statement. Alright? So by using this await, we are requesting Dart to wait for certain time before executing the code below it. So without completion of this code, Dart cannot move with execution of other code below it. So whenever we use this await statement inside of a function, that function must be of async type. So between the parenthesis and curly bracket of a function, we use this async statement. By using this async statement in a function, we are notifying Dart that there are code inside of this function that might take some time to execute. Alright? So if you are using await statement inside of a function, this function must be of async type. So let me comment this print for now. And now if I run this code, You can see that task 1 is complete. There is a delay of 1 second, and then task 2 and 3 is complete. Alright. So by using async and await statement, we got the desired results. So now if this delay was for an actual API request, then this response will show the data from the API. Alright. So there's one thing we need to keep in mind while working with an async function. So when a function is async, we need to wrap this return type with a future. So future, open angle bracket, and this return type needs to be wrapped with this angle brackets of future. By using this future statement in our function, we are notifying Dart that there are code inside of this function that might delay, and if there is something to be returned from this function, this might take some time to return, and it will be returned in the future. Alright, so the future keyword. And as we are returning nothing from here, and this function was originally a void, so future void. Alright, so in the next lesson we will be using this async, await and future statement for getting the results from our API. So I'll see you at the next lesson.